Let me show you how to do it with this one, and then we'll talk about, there are 6 basic shapes, and we'll talk about all of them.
6, okay.
Yeah. So for this one, for the intercepts, you're just finding where it hits each axis. So for example, if I want to figure out where it hits the z-axis, I'll plug in x equals 0, y equals 0. So for the z-intercept, x equals 0, y equals 0 says z is going to equal 0. And actually, for this particular example, it's extremely simple the way well, this example is really simple. If I want the y-intercept, I plug in x equals 0, z equals 0, that gives me y equals 0, and then the same. So because it hits the origin, that's the intercept on all 3 axes. So all of the intercepts are going to be at the origin. But in general, you know, you just plug in zeros for 2 of the variables, and then it tells you where you're going to hit the axis. That's a little bit useful. What's more useful is the traces. So for the traces, what I'm going to do is, for example, plug in z equals some constant. So I'm slicing my surface with the horizontal plane. And when I do that, it will give me some, what do you call it? Some quadratic curve. So it will be an ellipse, or a hyperbola, or a parabola. Let's go ahead and plug in z equals k. So I could plug in z equals 0. Z equals k is a little bit more general, and it allows you to see more of the traces. So if I plug in z equals k, I get k equals x squared plus y squared. So that tells me that when I cut this with z equals k, I'm getting a circle. It's a circle of radius square root k. So, for example, the graph can't go below the xy plane because k can't be negative. So I already know something about this surface. It's going to start here at the vertex, and it's going to go up, and as it goes up, I'm going to get circles. And what can you tell me about the nature of those circles as I'm going up? How do they relate to each other? In other words, are they getting bigger, smaller, or neither? Neither? So as I plug in larger and larger values of z, what's happening to the radius of the circle?
Oh, it gets bigger.
Yeah, it's going to get bigger. So as I'm going up, this is starting to expand out.
So in this case, given the value z, the circle is on the xy plane, centered at the origin, and it just goes wider and wider and wider because the radius, which is z, is growing bigger and bigger and bigger.
That's right. Yeah.
But again, it's the circle is lying on the xy plane, and it's sort of traveling up or down the z-axis.
Yes. All of these circles are parallel. They're all in a plane z equals k, so they're all parallel to the xy plane. And I'm thinking of them as sort of going up and down the z-axis. That's right. They're going to be symmetric about that axis. And of course, I chose a particularly simple example. If I chose something with other x and y terms, you could complete the square on it and see sort of where it's centered using a shift. If the x squared and the y squared had other positive coefficients in front, then this would be, in general, an ellipse. But if the positive numbers in front are the same number, then you get a circle. All right, if I plug in y equals k, I get z equals x squared plus k squared. I'm thinking of k as a constant. So remember, a y equals k, since this is the y-axis, y equals k means I'm slicing with sort of a vertical plane. If the origin is down there in the room, and the z-axis is that corner of the room, then a y equals k is a wall that's coming straight out orthogonal to the board. And when I slice this object, I'm getting this. What kind of curve is this in 2 dimensions?
Parabola?
Yeah, it's a
Yeah.
parabola.
It's
And
constant.
what's the k-squared doing here?
So it's transitioning it up k-squared units.
That's right, it's just moving it up k-squared. So parabola, does this parabola open up or down in the z direction? Yeah. Parabola opening up. And then for x equals k, I'm getting the same thing. Another parabola opening up. And so as I go out in the y direction, these parabolas are just moving up and up and up. As I move out in the x direction, the parabolas are moving up and up and up. You guys may be able to tell me now how I can draw this, or what does this shape look like, this 3D surface?
It's on the YZ plane. It's a parabola on the YZ plane.
Okay, are you talking about this
Yeah.
curve? Okay. Yeah, this is another parabola opening up in the YZ plane. Good. So I can sketch that parabola. It's a little hard to sketch. Can you see in your mind what this 3D surface will look like? Yeah, good. It's going to look like a cup. It starts here at the origin, and then as you go up, it just expands out like this. As you come in, it doesn't hit a sharp point. And I think the way that you can see that is just by thinking of the parabolas. You know that parabolas don't come to a sharp point, they come to a curved point. So as this goes up, you're getting these circles. The circles, are looking like this, and then those parabolas, if we cut with y equals k, the parabolas are looking something like this. And if you cut with x equals k, they're going to be maybe a little harder for me to draw, but I think they'll look something like this. And then as you move backwards, you would have some back here as well. And then these red ones are moving left to right. So there's another one. Something like that in the middle. So this one turns out to be a relatively simple object, and most of these are pretty simple surfaces. The name of this thing, since 2 of the traces are parabolas, we'll call it a paraboloid. And then since the other trace is a circle or an ellipse, it's usually called an elliptic paraboloid. You could call it a circular paraboloid as well. I do want you to be able to give me these names. I just want you to be familiar with the terms.
So on the left hand, you have the intercepts. On the right hand, those are traces. And
Yeah.
they're equations.
That's right. These are traces, and these are intercepts. So the traces give you 2D curves, and the intercepts just give you points. All right. I'll go ahead and give you the other shapes, and we'll think about what equations match up with those shapes. So I think I'll go ahead and put those here. Before I erase the rest of the traces, does anybody want to ask any other questions on this particular shape?
How much does the drawing count for points-wise? Like, does it need to be like a super good drawing or just?
It doesn't need to be an awesome drawing.
All right.
But I do want to see that you try to take the information that you gave. Like, if I asked you to give me the intercepts and the traces, I do want to see that that you made the connection between those things.
And pretty much just make sure the traces and intercepts are there, and then the rest of it is kind of right.
Yeah, yeah. So it doesn't, it doesn't have to be perfect, but if you just did something like this, I wouldn't be very happy with that. I mean, it's okay, I can tell what you're drawing, and I know that you know the basic shape, but I would rather see that you took time to make sure it went through the correct intercept, and maybe you sketched a couple of traces or something. All right, so, yes?
When you're trying to find the traces, should we use, like, set y and x equal to 0?
That's a good question. I think in all the solutions that I gave you guys, I set them all equal to 0. Setting them equal to 0 gives you some important information. Setting them equal to k gives you more general information. So I think it's probably more helpful to just set up the k and then look at 0 first and see what's happening there, and then move on, think about what it looks like for the other values of k. But if you just plug in 0, 0, 0, I wouldn't count off any points, for example.